So welcome. I'm Bill Schlesinger, president of the Cary Institute. It's good to see you all here this morning on a day when the competition of a beautiful spring morning is certainly severe. This is one of our science and management forums that we do a couple of times a year in an attempt to provide to those that most need it an examination of where the science is on various subjects that impact the public, impact management of resources in this area, and essentially environmental oversight that makes our daily lives more functional. There's probably nothing that has been in our lives kind of in your face more recently than some of the recent floods in this area, with Hurricane Sandy, Hurricane Irene, Hurricane Lee, causing a great deal of flooding. I don't know whether that's climate change or not, but I'd certainly say that they fall into the category of the weird or extreme events that one hears with global climate change models. But regardless of that, as to whether those might be linked to global warming, as it were, certainly I think they've alerted our attention to the fact that this area is vulnerable to floods, that the floods can be really significant and perhaps of increasing frequency, and that we all need to be better prepared to do that. Of course, Cary and Cornell Cooperative Extension, that are kind of the prime leaders of this, have a long history of work in this area. So we're not only pleased that you're here today, but we're kind of proud that this is the forum in which we can offer some science that might be useful in your daily lives. And I think the real importance for things today is to, what we want to have as a take-home message is essentially to review some of the impacts that we've seen in some of these recent floods, to think about how we might manage better both our land management, water management in the future, what to expect in the future, and how to plan for that, all regarding around extreme hydrologic events that may impact our daily lives. So on behalf of the Cary Institute, I want to welcome you here today. I think this is going to be a really fascinating morning, and we will see what the science brings to bear on the issue. I want to introduce my compatriot here, Carolyn Clocker, who is from Cornell Cooperative Extension, who may have a few words, and particularly if I get unleashed here, she will find it easier to say.
Thanks, Bill. On behalf of Cornell Cooperative Extension, thank you for attending. We're very excited to be hosting yet again another Science and Manage Forum with the Cary Institute. This has been a very fruitful partnership, and we've been able to put several of these together over the last several years, and we hope to continue to do so in the future. And as Bill said, this is an extremely pertinent topic right now, and we're very excited that you are all here to learn more about the science, and then learn from some of your colleagues as well as what they're doing to start addressing flooding in a management sense. This project has come to Cornell Cooperative Extension in the organization of this forum and several other initiatives that we have started here in Dutchess County and several other counties this year as part of a larger project called the Hudson Estuary Watershed Resiliency Project. And this project is a combination of research, demonstration, and educational outreach projects to address challenges of flooding and stream management and watershed management, along with the changes that we'll be seeing due to climate change. As part of this project, Cornell University and the Cornell Cooperative Extension, in partnership with the New York State Water Resource Institute at Cornell University and the Hudson River Estuary Program, part of the New York State Department of Environmental Conservation, is conducting this educational initiative with a focus on flood resiliency and climate change. As part of this project, Cooperative Extension educators in Dutchess, Putnam, Orange, Columbia, and Greene counties are actually going out to the municipalities and meeting with town boards and putting together educational forum opportunities like this and workshops as well. We've also contracted with the soil and water conservation districts in the region to do training for highway supervisors on post-flood stream intervention. So you'll be hearing more information from us as we move along. This is just the first of many larger forums and educational opportunities that we are hoping to provide to you all as resources as we move forward in these changing times of increased precipitation and flooding. At this point, I'm not going to talk any more about that, but I do have a reminder for you all. When you walked in, you received these two sheets here. The ivory sheet is a pre-survey or pre-evaluation. Could you please, if you haven't already filled this out and turn it in, please do so right now. We would like to collect these from you before the presentations begin. And then the blue is your post-evaluation. So essentially, we will not let you leave this auditorium until you turn this one in. And especially if you're looking for a municipal training certificate, we will have them in the back of the auditorium at the end of our forum today, but I will not give you one until you've turned in your blue sheet. All right? These are extremely important to us because they are evaluating the effectiveness of the project, but they're also providing us feedback with what types of information you need, what types of trainings you all are looking for, and how we can make this program better suited to your needs. So it's extremely important to us if you take the time to fill those out. So thank you. I hope you enjoy today and get a lot out of it, and I'm going to turn it back over to Bill to introduce our first speaker.
So, Jessica Rennells is our first speaker. She's a fellow Cornellian, so we usually first identify with that. A climatologist with the Northeast Regional Climate Center, and an author of the ongoing but soon to be released National Climate Assessment. She was an author on the team that put together the review of the Northeastern region. And her role as in the Office of the Climatologist, of course, that effort is to gather, synthesize, review climate data, historical and recent, and try to get some idea of the means and extremes of what we have experienced in the past, and therefore the probability of what we may experience on into the future. So Jessica Rennells, without further ado.
Good morning. I'll be talking about climate change and extreme precipitation. We'll take a look at trends we've been seeing, and we'll also take a look at what we're going to expect in the future over the next century. So here's a look at global temperatures and kind of introduce, so what is climate change? So basically, it's a non-random change in the climate that takes place over decades or longer. So we're looking at the long term. So here we're looking at global average temperatures over sea and air temperatures. And you can clearly see the increase. And we've also plotted on here the CO2 concentrations, and you can see that they also increase with the temperatures. So CO2 is one of the major greenhouse gases that are concerned with climate change. These are the three major anthropogenic greenhouse gases, as well as carbon dioxide. There's also methane and nitrous oxide. You can see up to about 1800, it was pretty constant levels in the atmosphere. Once we get 1800 to 1900, there's a linear increase, and after 1900, it increases exponentially. So we have more burning of fossil fuels, industrial revolution. They're really increasing. Carbon dioxide is the greenhouse gas we talk about the most. A couple reasons for that is the concentrations are much larger in the atmosphere of CO2 than the other gases. It's about 84% of the greenhouse gases that are contributed by anthropogenically, where the other two are much smaller. The other big reason is how long it lasts in the atmosphere. CO2 is in the atmosphere for 100 years, which is a really long time. So what we're putting up there today is going to be up there for 100 years. So it's really important to look at what we're doing with that. Methane only lasts about 12 years. Nitrous oxide is in the atmosphere also a very long time, about 120 years, but its concentrations are much lower. So here's a look at global temperatures. We're comparing it to 1951 to 1980 period, and there's been about a 2-degree increase. And there's been a two-step increase. If we look at up to about 1940, there was increasing, and there's actually a slight decreasing period until about 1970, and then a steep increase after 1970. Here's another way to look at global temperatures. We have a kind of a graphic comparing the two different periods up there. Just basically to give you a visual that overall the globe is warming. There are a few cooling areas, but overall we're seeing warming. Take it down to the northeast, kind of get into our region. We're also warming. This goes all the way through 2012. You can see year-to-year variability, but overall the trend is that we're warming. I've also put a trend line in just for the last 30 years, and there's really been, for the last 30 years, a really big increase. We had the coldest year on record was 1917, and then the hottest year was last year, 2012. Take it even more at the local level. Look here at Hudson Valley, just plotted, just so you can see that what's happening globally is true for the local level as well. We have the interannual variability, but overall we're seeing this big increase. So as well as temperature is changing, it's affecting other things as well. So here's a look at the change in snow cover, so how much snow is on the ground. Overall, we can see in the region there's been a decrease in days. In this region, I think we're close to the 20 to 29 decrease in days in that period. So a lot of things are changing, not just temperatures. So streamflows, another thing to think about with climate change. So these are 13 rivers in the New England area. Shows over time, 1900 to 2000, and along the left-hand side is its Julian date, but that's starting from May 11th, and on top it goes through, March 11th through May 10th, so going further through time up the graph. And so we're looking at center of volume dates. So what that means at a particular stream gauge is at what point in time for a season has half the volume passed that gauge. And when you look at the graph at about 1970, there's a decrease. So during the past about 30 years, that center volume date has gone back in time about 1 to 2 weeks. So that's happening earlier in time. So what that's indicating is that snowmelt is happening earlier in the season. Our winters are getting shorter, that snowmelt is happening earlier, and we're seeing that affect our streams. And something to think about that is, when we think about spring flooding, so that can affect spring flooding time as well. Sea level rise, also something that definitely comes to mind with climate change. So here are 4 major cities in the Northeast, coastal cities. New York is plotted in blue, which is close to here. And there's been a big increase. Regionally, over the past 1,000 years, the rate of increase has been 3 to 4 tenths of an inch per decade. But what we've seen over the 20th century, and currently, we've seen 1.2 inches per decade. So that rate of increase in sea level has been more recently. If we look at specifically New York City, we've seen over the past 100 years that sea level has risen 1.2 feet. And that's about 4 inches more than the global average, about 8 inches. So we're seeing regionally a little bit more sea level rise. Part of that has to do with land subsidence, but overall sea level changing because not only is the air warming, but oceans are warming as well. So warmer waters, we have thermal expansion, they take up more volume. And ice sheets are melting, that's adding to the volume of water there. Some ocean currents and then the land subsidence are all adding to these sea level changes. So let's take a look at precipitation. So here's global mean precip over the century. And there's not a clear trend globally when we look at precip. So here's a graphic looking at the change. And you can see some areas are getting wetter, some areas are getting drier. Places that are getting drier, if we look at Africa and South America, are really getting drier. If we take a look up at the Northeast, we're getting wetter. So here's a plot of the Northeast. Same as temperature, there's year-to-year variability, but overall, here we are getting wetter. We've had an increase of almost 6 inches throughout the year, and this plot goes all the way up to 2012 through last year. What's evident too on this graph, if you look, you'll see the 60s drought is pretty clear. So there has been changes. And after we get from 1970 to present, we see more variability and more of these higher years. So again, I try to bring it in on a regional level, and we can see the 60s drought, you can really see. But you can also see that it's been increasing and more variability in the more recent years. So again, what's happening in the Northeast is true on the local level. So this, we've broken it down into the seasons to see how things are changing, looking at the different seasons. And the only season that we're seeing a clear trend is in the fall. So there we are seeing the fall is getting wetter. Another notable thing is if we look at summer precip, even though there's no clear trend, our wettest years, 2006 and 2009, are in the more recent periods. That's just kind of a little bit noteworthy. So now let's get into some extreme precipitation events. This is for trends over the U.S., so we're not on the local level yet. We're looking at a 2-day, 5-year event. So we look at extreme precipitation in a lot of different ways and over different time periods and different intensities. So here we're looking at how much precip falls in 2 days. And a 5-year event means that there's a 1 in 5 chance any year that this precipitation will occur. So if we look at this plot, you can see in the recent years it has increased. Now the scale is only 0.4, so it's not a huge increase, but it is increasing. So let's look just at the Northeast. Now this, we're looking at 1 day, so only how much precip is falling just 1 day, very heavy precipitation. That's defined as the top 1%. So the highest 1% of precip events, and how has that changed? And if we look at the 2000s, it's increased by 45%. So we're really seeing an increase in the Northeast. Kind of a little bit of background of why we're seeing some of these increased events is we have to think that, as the air is warming, we're seeing these warmer temperatures, there's an increased capacity to hold moisture. So as the air can hold more moisture, we're going to see more precipitation. So here's a kind of U.S. view of how things are changing. Again, we're looking at this 1 day, 1% heavy precipitation events. And while the whole U.S. is changing overall, it's the Northeast that has the biggest increase by 74%. And that is comparing with the 1901 to 1960 average. So that's been increased. And this plot is basically the same thing. We're looking at water vapor instead of those top precip events. And we'll see that we also have the biggest increase in water vapor. So that really goes hand in hand with the precipitation. More water vapor, more precip events. So I picked a station close by in West Point and say, all right, let's really get local and let's see what's going on with the heavy precip. So I plotted number of days with 2 inches or more in 1 day. And it was very clear that those have increased from about 1 event to closer to 3 events. So again, it's really happening here on the local level as well. And I should mention, we look at 2011 having, it had been 8 days in 2011, and I kind of jumped ahead, but we can think of what one of those was, and it was, of course, Tropical Storm Irene, which brought a lot of precipitation to this area specifically. And so this is a cool satellite picture from NASA showing all that moisture. So this is a 3-day accumulation from Tropical Storm Irene. You can see a lot of that heavy precip is right in the area where we are today. This is a site I've taken from precip.net. It was worked on by some colleagues of mine. And really, it's a great site for looking at different extreme events and plotting how extreme they are. So I said, all right, I want to look at 1 day events, and I want to look at August 28, 2011. So what this shows, it says, okay, how much fell in that 1 day, and how does that rank for that particular station based on historical data? So if you look at Slide Mountain in purple, they were classified as a 200-year storm. They had 8.62 inches. So based on the historical data for that station, the rain amount that fell on that particular day should only occur a 1 in 200 chance that we'll have that much precipitation. Some other big stations, we look at Rosendale and Mohawk Lake, they were 100-year storms. And that means that we'd have a 1 in 100 chance that this much precipitation would fall. And I should also know that these are not 100-year floods, these are 100-year precipitation events, which are different because we're only looking at precip. So we're not taking in account soil conditions and how high the rivers were. These are just looking at the precip. I think a lot of this area actually had flood events that were more than what these storm events were. So what's going to happen in the future? So we look at climate models and different emission scenarios to try to predict what we think is going to happen over the next 100 years. And it's a really difficult task. If we think, what was the world like in 1913? A lot different than it is today. So we're trying to think, okay, the next 100 years, what is the environment going to be like, population, politics, all those things, play into what our emissions are going to be like. So it's kind of a messy graph, but it's basically looking at different emission scenarios, what we think may the world be like. So we look at the red dotted line. That's a high scenario, high emission scenario. In that case, CO2 levels increase about 4 times their pre-industrial value by the end of the century, 2100. It's a fossil fuel intense society, rapid economic growth, and a modest increase in population. If we look at the brown line, our gold line, we kind of call that one the business as usual scenario. Basically, we look at trends that we're seeing now, and we say, okay, that trend is going to continue. And some of these other scenarios are more a decrease in emissions, really kind of environmental, trying to reduce emissions. But we have to think about, even though we're going to say we're going to be reducing emissions, overall CO2 concentrations are still going to increase. That's because the CO2 lasts in the atmosphere for 100 years. So we're adding to the CO2 that's already there. So how do those play into what we think these 100-year storms are going to look like? This is based on different stations throughout New York State. And so it's looking at the frequency and the intensity of these events. So based on these New York stations, kind of an accumulation, if we look at first at the return period, so how often these storms occur. So what was considered a 100-year storm by mid to late century is now an 80-year storm. So we're seeing expecting these events to occur more often. And if we look at the intensity, how much rainfall is associated with these events, that's also increasing, about 0.2 of an inch for what these stations were. So we're seeing more often and heavier precip of these events. One paper that used this model is suggesting that this actually underestimates this, so that we actually may be seeing even more than an 80-year storm and even more precipitation. So this, we're looking at a 1-day, 20-year event. So again, how much precip falls in 1 day on a 1 in 20 chance. There's 2 separate models, so both looking at the same thing. We're comparing kind of the recent history, 1981 through 2000, and comparing what we think that'll be like late in the century, 2081 to 2100. So in the graph on the left, this is a low pathway or a low emission scenario. We're saying that this 1-day, 20-year event will change 1 to 2 change multipliers. So maybe it'll stay the same, maybe it'll double. But if we look at the high emission scenario, we're looking at a 3 to 4 change multiplier. So if we have the high emission scenario is bad case, we really see these events increasing. So here we're looking at, again, heavy precipitation. We're looking at events, days with 1 inch or more. So we look at climatology, so 1981 through 2000. We're seeing about 8 to 10 days currently in our area with that much precip. But when we project that out to mid-century, 2041 to 2070, we're looking at an increase of 12 to 24%. So even just these 1 inch precipitation events are going to be increasing as well. So overall, heavy precipitation we plan on seeing that these increase over time. Atmosphere is warming, it's holding more water, and more of these events are occurring. So I'm going to switch and take a little bit look at temperature. This is New York City station. The black line is what's been observed, and then these are some of the different emission scenarios. Kind of the pink shaded areas, kind of like the middle, 67% over the different models. I think the real kind of take-home message from this slide is that even if you look at the yellow line, the very minimum, which is an outlier and not as likely, it's still increasing. So the temperatures over all the climate models and all emission scenarios are increasing. So another look at temperature, we think about not just average temperatures increasing, but some heat extreme events like heat waves. So heat waves, we looked at days of 90 degrees or above. So here we're looking at New York City, and currently about 15 days of 90 or more. And then these are the yellow is the low emission scenario, and red is the high emission scenario. And obviously, as we go later in the century, we're seeing both of those increase. And then the high emission scenario showing more days than the low emissions. But if we look at the end of the century, we're looking at close to 40 days of 90, high emissions, 70 days of 90. That's just almost infallible for me. It's just that's a lot of hot days. You look at days over 100, 7 to 25 based on the different emission scenarios. So some hot days. Another thing to think about is heat index. So that's kind of how hot it feels. So it takes into account not only temperature but relative humidity. So as we're saying, the air is warmer and holding more moisture. It's going to be more humid. So we combine those hot temperatures and the humidity, it's going to feel warmer. So this graph kind of says, okay, where's it going to feel like we're living? So maybe under low emissions by the end of the century, it'll feel like Virginia. And maybe under the high emissions, it'll feel like South Carolina or Georgia. So it's just kind of a different way to think about it.
Are you taking questions with these slides as you go?
Sure.
Okay. Can you explain on the upstate map where you see New England to the right and you see the yellow sections here? Mm-hmm. It's almost a sheer cut. What causes that difference that you're seeing in the yellow part to the left and the white part to the right?
Well, they were in this research. They were only looking at New York, so they weren't looking at the other states. So they're only looking at what's in the yellow and the red. They didn't look at the New England states. They were only looking at New York. And it did cut off, it's just like upstate New York, so it kind of cut off where part of we are today. But it would be similar for the rest of New York as well. Another thing to think about is seasonality. So there's kind of a lot going on in these charts. The precip is more exciting than the temperatures. So we're kind of comparing winter and summer, how things are going to be changing. And then they look at mid-century, late century in different scenarios. Basically, if we look at temperatures, winter and summer, we see them both increasing. And the interesting one is the precip. If we look at winter precip, that's where we see our increase. We look at summer, we're looking at hardly any increase or maybe even a decrease in summer precip. So when we looked at, earlier we looked at the precipitation, we're saying, okay, we're going to see more precip in the Northeast. Well, more of that is going to be coming in winter and less in summer. And also, as we're getting more temperatures, more of that winter precip is going to be more as rain rather than snow. So we think about summer drought as we're getting less summer precipitation. We look at climatology. We have a number of, it's basically dry days, precip less than 3 millimeters. So how many dry days are we getting? So currently we're looking at 20 to 27 days, and then we're getting maybe up to 2 more days of dry days. Basically, we're expecting summer drought to increase. As more of a precip is going to be coming in winter, and also more of these hot temperatures that we're going to see all year, but also in the summer. Hot temperatures can really increase evaporation, dry out our bound. We're getting less rain, so we're going to see more summer droughts. Under the higher emission scenario, we're expecting short-term droughts could occur as often as once every year. And snowfall, so this is actually snow cover. So as well as temperatures increasing and more precipitation falling as rain rather than snow, and what snow does fall is going to be melting more, so the warm temperatures not staying in the ground as long. The red outline is currently where we see at least 30 days of a trace of snow, so a little bit of snow cover. This is under the high emission scenario, not the low emissions, but under the high emissions by late in the century. This is the only area left that would have at least 30 days of snow cover. So that's a big difference. So sea level rise. We talked about the sea level is already rising. It's increasing every year. So under the different scenarios, what are we going to expect in the future? These show a range for each of the periods throughout the next century. And these are range between the low and high emission scenarios, so kind of a range of what they show. So the light blue is the range. We look at the dark blue, that takes into account the rapid ice melt. So there is some thought that the current scenarios and models don't take into account how fast some of this ice may melt, because we're not exactly sure. So if we take that into account, sea level rises even faster. So we look at New York City and Troy. Even though Troy is not coastal, of course we have the Hudson Valley, or Hudson River that's going to be pushing the water up to us here. So we're really seeing some big increases by the end of the century. So again, that has to do with, as the water is warming, we're getting thermal expansion, ice sheets and glaciers are melting, and we've got the land subsidence here as well. So that's all increasing. The global sea level rise is expected to be by 2100, 1 to 4 feet. And we tend to be a few inches above that here locally. Just thought with that I should mention salt front migration, since that's an issue here locally. As sea level rises, it's going to be pushing that salt water up the Hudson. And there's such a non-steep slope of the river that also adds to that. Reduced precip, increased temperature, more evaporation, so more salt. So let's talk about hurricanes. So this is looking at the change in frequency of hurricanes between kind of the 2001 to 2020 period, so more about a local period, to the end of the century, 2081 to 2100. So you can see that the tropical storms and the smaller scale hurricanes might actually decrease a little, but it's the category 4 and 5, the major hurricanes, that are expected to increase by up to 75%. So this is, by the end of the century, but it's a big increase. And just to take a look back, what we've seen historically, this is kind of a combination of hurricane intensity and number of the category 3 and 4 hurricanes. So just showing that historically we have seen that increase, and we'll see that continue. The category 3 and 4s, category 4 has sustained winds of 111 miles per hour or higher, and the category 5 is 130 miles per hour or higher, so big storms. So we've talked about kind of these extreme precipitation events that can be flood producing. So these can come from a lot of different weather events. So we've talked, about Irene, so we know tropical storms are something that can lead to flooding. But it's also just frontal systems and thunderstorms that can be producing these heavy events as well. Coastal storms, nor'easters. These are all things that are going to be bringing more precipitation to the northeast in the local area. But there are other factors, and climate change affects those other factors as well. So there's a lot of things to think about. If we think of the soil conditions, especially with Irene, we did get a lot of rain in that event. I mean, we had those 100-year rain events. But August was also a very wet month. So had the ground not been already saturated, maybe the flooding wouldn't have been quite so bad. So how is that going to change? Well, maybe if we have these drier summers, then maybe that'll alleviate a little bit of flooding. But then we look at, rain on snow events. Well, we think, okay, we're going to have less snow, we'll have less rain on snow events. But then on the other hand, when we're kind of in this transition period, it's not going to be all of a sudden there's no snow, but we're getting more rain. Maybe we'll have more rain on snow events. So there's kind of a lot of different things to think about. And obviously not affected by climate change, but infrastructure, impervious surfaces, the more pavement we have, the more runoff, more flooding, and pollutants in the water, and that kind of thing. So just a lot that goes into flooding and these extreme events to think about. So are there any questions?
Talk a little bit more about the salt front, how it will affect us.
Sure. It's, I have to admit that's not my area of expertise, but basically as sea level is rising, the ocean waters get pushed up. So there's the front where basically the fresh water and the salt water meet, and as sea level rises, the ocean water gets pushed up the Hudson and it gets pushed up here. And how the precip and the temperatures play into that is basically as we have less precip, so we have less fresh water to dilute that, and as there's more evaporation, when water evaporates, it's just the water and it leaves the salt behind, so that can increase the concentrations of the salt in the water. Yeah?
The Chelsea's pump system is for the New York City Board or
Someone said yes, I'll trust them.
it's not used anymore in the program life.
Other questions? All right, thanks. Beautiful.
Slope River. That basically Slope River bed.
I don't know. I mean, I know it's a slope of the overall river. I guess I would assume that it would have to be the bed as well as the surface.
This is the water surface elevation. Difference in mean water level at Troy versus New York City.
Could you go back to the very last slide in terms of the,
This one?
no, one more?
Oh, here.
Yeah, the 100-year storm concept.
Yes.
I mean, do we still consider it the 100? I mean, it's the 100-year storm.
So basically, we have to kind of keep redefining what the 100-year storm is as we go through history, because so right now, we're saying it's a 100-year, but we're saying okay, at some point it's not going to be a 100-year storm anymore. So we need to keep reevaluating, what this is, because you're right. At some point, the 100-year storm will be a higher precip amount, and what we consider a 100-year storm now will be the 80-year storm with a different precip amount. So we have to kind of keep evaluating as we keep getting these events. Yes.
Hi. I live in a floodplain, so I know that in 2009, the New York State building standards were revised so that the new 100-year flood for building in the code is 2 feet over 100 year. Do you know if there is a proposed revision of that in the works already? There should be, but is there?
I do not know. Okay. I don't. But that's something that we definitely want people to look at when they are making those floodplain maps, and with the new infrastructure to take an effect that we're going to get more of these big events, and that we need to plan for that.
Say we're getting more hurricane 4 to 5 level. What is that? It was Irene 4 to 5.
Well, Irene was a Category 3, I believe, but by the time she got here, she was only a tropical storm. So that means basically the winds were below 75 miles per hour. So the winds had decreased, so it wasn't categorized as a hurricane anymore. But it was still a very large storm. It was still organized, so it still had the rotation to it, and it had all that moisture that dumped all the precip here. So I think that's something that's likely to hopefully continue, that we won't actually get Category 3s running into New York, but they will be, at some point be, in the Atlantic Basin, be Category 3s and 4s. It will be occurring more often. But if they come up the coast and run into land, it's likely that they'll decrease. But the bigger they start, the bigger they're going to be by the time they get here.
Do you have data on what precipitation was for Sandy?
Not with me, but I do, and I can definitely get that to you.
So right here is about 0.55 inches.
And what was Irene?
That I have.
6, 7 inches.
Yeah, some had 8 inches at Slide Mountain, I think. Here we go. Yeah, so Slide Mountain had 8.62 inches. And then Rosendale had 8.5, Mohawk 8.21. And that was just in one day. There was some precip surrounding those days, but this was the heaviest day.
As the 100-year storms are being redefined, are floodplains also being redefined, or are they being moved, those lines, the floodplain lines being moved?
Well, I don't work on the policy side of things, but I mean, that's my hope, and I think that people are looking at this more, and I think FEMA is reevaluating. I know after Irene, I think there was some reevaluation done by FEMA.
There are likely, I realize, going to be probably a lot of questions today about floodplains and floodplain mapping. I don't know if any of our speakers are going to be addressing that specifically, but you should know actually that we are in the process of securing Bill Neckerman as a speaker for a seminar in June to deal with those questions. We thought about having him here today, but we realized only giving a half hour to those types of questions would not be long enough. So if you do have future questions about FEMA floodplain mapping and changes that were done through the insurance program and things like that, make sure that you sign up and sign into the event and have your email address there, because probably by Monday or Tuesday of next week we will have names and locations selected for that particular talk, and it will actually be hosted twice throughout the region. So I just want to let you know, if you have those types of questions and we aren't able to answer them for you today, that our hope is that in June you'll be able to attend one of the two events that we're organizing to get those answers addressed and more questions addressed.
Okay. Thank you. Our next speaker is our own Stuart Finney, senior scientist here at